Bismillahirrahmanirrahim. Dear viewers, Assalamu alaikum. My immediate last video was on atomic bomb and nuclear reactor, how they work. That was basically the first part of this atomic bomb and nuclear reactor stuff. I'll make more videos on the remaining stuff about atomic bomb and nuclear reactor. But before that, I felt the need of making certain corrections and clarifications and explanations also uh, related to the first part of my video, which I delivered yesterday. Now, the very first uh, explanation which I want to make is that in my uh, last video yesterday, I explained in nuclear fission, and I told that when uranium 235 captures one neutron, it becomes uranium 236. And when uranium 236 splits apart into two new elements, that is barium and krypton, it releases three neutrons and energy. So when one neutron is absorbed by uranium 235, it becomes uranium 236, and uranium 236 splits apart to yield four things: barium, krypton, three neutron, and energy. So products are four. Now, if you add the mass number of barium and krypton, that is 141 and 92, 141 plus 92, it becomes 233. Now, this uranium 236, when it split apart, it has released three neutrons. So 236 minus 233 is equal to 3. So these three neutrons are released and these two new elements are formed. But the important thing which you need to remember here is that the atomic number of uranium is 92, that is, it has 92 protons, and the atomic number of barium and krypton put together is also 92. 56 plus 36 is 92. But the neutron of both barium and krypton, if we add together, do not uh, do not make 236. They make 233. So three neutrons are released and energy is also released. This process is called nuclear fission. When a heavy atom is split, basically the nucleus of a heavy atom is split into smaller daughter nuclei, that process is called nuclear fission. Now, in the very first generation, when one neutron was absorbed by one atom of uranium 235, how many neutrons were released? Three neutrons were released. Now, when these three neutrons were released, these three neutrons hit three atoms of uranium 235. When they hit three atoms of uranium 235, nine neutrons were released. And when these nine neutrons, they hit nine atoms of uranium 235, 27 neutrons were released. So every this generation gives three times more number of neutrons. So In 55, about 55 generations, the entire fission process of the critical mass is completed in 55 generations. 55 generations means in first generation, that was zero generation. In zero generation, one neutron hit one atom, and in the second generation, three neutron hit three atoms and yielded nine neutron, and in the third generation, nine neutrons and yielded hit nine atoms of uranium 235 and yielded 27 neutrons. So in this way, in 55 generations, the critical mass of uranium is burnt and the entire energy is released, and the total time taken in the burning of the entire fissile material, which is the critical mass. I'll come to it later, how much is the critical mass of uranium to be used in an atomic bomb. 55 generations of fission are required, and the time taken is 10 raised to the power minus 9 seconds, that is 1 microsecond. 1 microsecond. In 1 microsecond, the entire process of nuclear fission, this is also called chain reaction, this completes. Now, this was the clarification which I wanted to make. And let me tell you, the total number of atoms in the critical mass is 1.7 into 10 raised to power 26. This is the total number of atoms. And it means these number of atoms are to be split apart. It means this number of fissions are required. And this number of fissions equals 55 generations. In 55 generations, 10 raised to the power 26 atoms split apart. In how much time? In 1 microsecond. This was the first point which needed explanation. That's why I am making this very short video, which is related to my last video which I made yesterday. The second point was that in the video which I delivered yesterday, I said that the critical mass of uranium used in an atomic bomb is 62 kilograms. Well, it is not 62 kilograms. Theoretically speaking, critical mass is 52 kilograms. It is 52 kilograms. It is not 62 kilograms. And the amount of uranium 235 which was used in Hiroshima bomb, the atomic bomb which was dropped on Hiroshima on 6th of August 1945, the weight was, whatever you call it, 64 kilograms. It was not 62 kilograms, not 52 kilograms. Although the critical mass is 52 kilograms, but they used 64 kilogram in the atomic bomb to make sure that maximum destruction takes place. Now, this was the second point which I wanted to make correction on. And the third point was that in my last video, I mistakenly, or you can say by slip of tongue, I told that the amount of uranium 235 found in the natural uranium is 0.27%. That's what I said. No, it is not 0.27%. It is 0.7%. It is 0.7%. 7%. Now let me explain. Uranium 238 is 99.27%. I said in my last video 99.3%, which is almost equal to 99.27%. But the exact percentage of uranium 238 in natural uranium is 99.27%. And uranium 234 is very negligible, which is 0.006%. And uranium 235 is 0.7%. So this was the third point which I wanted to correct or clarify or explain further. Now, another slip of the tongue was that I said that the significant deposits of uranium are found in 4 countries: Canada, America, Namibia, Kazakhstan. No, it was not America. It was slip of the tongue. It was Australia, Canada, Australia, Namibia, and Kazakhstan. These are the 4 countries where significant amounts of uranium are found. Although uranium is found in other countries also, in Pakistan also. But these 4 countries have maximum amount of uranium in their soil, and maximum mining is done in these countries. So these were the 4 points, dear viewers, which I wanted to explain further or make correction related to the previous video which I made yesterday. So thank you very much, and Allah Hafiz.